Hello, good evening. My name is Juan Hernández Martín, and this video is about the reinforcement learning algorithm. This algorithm combines the heuristics with the brute force, and it can be used to solve any problem that can be specified using a reasonable number of states. It has three main components: the ambient, the agent, and the interpreter. The basic idea is to train the agent to take the correct actions by punishing or rewarding it. The actions that are rewarded are more likely to be done again. When the training is done, the agent should take the action that will lead to the goal. The ambient is the first element, and it's a data structure containing all the possible states of the problem and all the transitions between them. There should be only one initial state, but there can be any number of final ones. With every interaction, first is sent to the agent the information of the actual state of the problem. Then it waits until the agent decides to make an action. When the message with the action arrives, it sends to the interpreter the information of that state. The second element is the agent. It consists of another data structure that assigns a probability value to each one of the transitions. The way it works starts when it receives the message from the ambient containing the state. After that, it searches all the transitions that begins with such a state. Using the probability values that each one has, it chooses one of them. The better the probability, the better the value should be. Once the action has been chosen, the agent sends it a message to the ambient. Then it has to wait until the interpreter qualifies the next state, and then with the information that it receives from the interpreter, it modifies the values of the data structure. The interpreter is the last element, and it contains all the heuristics and all the methods that can be used to qualify how good is a state. Start working when the message from the ambient arrives. This message contains all the information that is needed. With this information, the interpreter qualifies the state with heuristics, and then it sends the information to the agents. For example, I can use this tic-tac-toe game to show what could be a way to represent the information that we should store in each of these tables. These are used to represent the information of the states and transitions, and this should be the ambient. This is the agent, and it stores all the values assigned to each one of the transitions. And this one is the heuristic. This one is not strictly speaking a data structure, so but you have to include here the methods that will be used to qualify one of these states. This algorithm has some advantages. Like, for example, you can use it with a lot of agents to try to reduce the execution time, and it's pretty easy to implement if we compare it to others. And we can use it with every problem that can be solved with a Turing machine, can be solved with this algorithm. because it works with any state, so it's very reliable. But it is not everything perfect, and there's some issues with this algorithm. For example, the amount of memory needed to do these problems is very large in comparison to others, because since the very beginning you have to declare all the states and transitions, and maybe those are need a lot of space. For example, in games like chess or whatever, in this case you need to take another approach, because you don't have an infinite memory. You have to also search for all the transitions in every interaction, so it's not especially fast when it comes to training. And it also depends on the heuristics. There are some of some algorithms doesn't depend on any heuristic invented by humans, because we are not perfect. For example, a neural network, you don't have to do a heuristic to make a neural network work, but you do in this algorithm. Heuristics are not always good, as we think. So also it shares with neural networks a bad thing, that is a black box. What this means is that the knowledge that it creates is not clear to a human mind. So this thing has inside a lot of numbers. You cannot use this information to know why it chooses one way or other. And that's it. Hope you enjoyed. Goodbye.